Okay, hi everyone. So what we're looking at today is fossil records and how does that provide evidence for evolution. Okay, so paleontology is not just the study of dinosaurs, as most people think, it's actually the study of fossils. And fossils are the preserved remains from a once living organism. They are actually, in fact, important evidence for evolution. So let's move on. Now, you'll probably remember this from grade 8, but there are three main types of rock: igneous, sedimentary, and metamorphic rock. Now, the type of rock that we're interested in is sedimentary rock. And this basically happens when sediments form from the environment being broken down and rocks being broken down into powdery sediment, and then these layers being compacted layer by layer by layer. Now what happens is fossils accumulate in these layers and the layers form what we know as strata. Okay, so the most likely places that fossilization occurs is in seas and lakes, and that's because of a slow accumulation of sediment and also the fact that the conditions are quite stable in seas instead of out in the open when they're exposed to wind and other environmental conditions. So the strata of sedimentary rocks are laid down, fossils are trapped within them, and then they're preserved. Later on, they're dug up by paleontologists and examined. Okay, so fossilization is actually the process of preservation of organisms' remains. As I said, it happens when organisms are compressed under layers of sediment in sedimentary rock. We call these layers strata. What happens, or what can happen, is the sediments form, the organism within the sediment decays and actually just leaves a mold. And this can actually be cast so that paleontologists can examine it. Alright, so what we can actually take from the sedimentary rock and fossils, we actually can see these strata, which you can see here, and we can figure out that the bottom layers are the oldest layers of rock and therefore have the oldest fossil specimens and therefore the oldest species within them, and therefore are not okay, so there's actually different types of fossil evidence, as you would probably know. Indirect fossil evidence is basically where the actual fossil is not there but has left sort of a print or something to that effect in the rock. So this might be footprints, tracks, teeth marks, nests, burrows, or even feces. So it's not the actual remains of the organism, but it's some sort of trace of them. So it's a trace fossil. There's also direct fossil evidence, which is direct pieces of fossil, which could be bones, teeth, leaves, and shells. Okay, and you can see here, this is obviously a direct fossil, and this is obviously an indirect fossil. Okay, fossil records show the changing patterns of living organisms on Earth over a long period of time. Okay, so however, fossil records do not give us the whole story. We have a whole evolutionary timescale mapped out, a lot of it based on fossils. However, this is our theory, we don't know for sure, and the reason for this is that dead organisms decompose quickly. Sometimes dead organisms are eaten by scavengers and therefore are not fossilized. Soft body organisms don't fossilize easily, so that means that some organisms may not have fossilized and may not be accounted for in our evolutionary picture and timescale. There's actually only a small number of organisms that will die in a way that is favorable to fossilization. So again, we don't know how much of the picture we actually know and how many other organisms might be out there that we haven't accounted for in our evolutionary picture and timescale. And there's only a small number of fossils that have actually been unearthed, so who knows how many others are out there. Okay, thank you for listening.